Hi, my name is Keith Tenzer, and today I'm incredibly excited to talk to you about some new ideas for how to build agents. I want to give a shout out to a colleague for some of his inspiration and thought leadership, and that is Neo Yuchin. And what I wanted to talk to you today is how we can mix the world of LLMs, tools, and MCPs with durable, reliable, mission-critical business processes that can execute as a temporal workflow. Think of payment systems or orders and being able to execute them through tool calls. But where we need it to be deterministic, it has to work the same way every time, and it must work without fail, of course. And I'm calling that durable agent skills. It's part skill.md, part temporal workflow. Since you might be new to Temporal, I just wanted to show our agent reference architecture. Temporal is a durable execution layer for building agentic systems. You can also use it for a lot of other things that don't have to do with agentic, but it is really good for agentic systems because it provides the reliability, durability, and observability on top of the flexibility. You can write temporal workflows in any language. You can use any frameworks or agent SDKs you want, and you can compose and decompose things to see how you see fit. So typically over here, we create an agent loop workflow in temporal that executes LLM calls, tool calls through activities and provide that durability, reliability. If the process crashes, if something goes wrong, we can pick up where we left off. We never lose anything. You can, of course, provide any LLM you want, and you can also do things like build an agent tool library with tools, MCP servers, and what I'm going to show you this new concept of durable skills. And front end that by Nexus, which is a API service contract. It's a service from Temporal that provides durability at the caller. So if you're not using Temporal over here, where you have retries and say something else, and you call a tool and it fails, you can do retries here. Nexus is a reliable service. And you can build this, of course, on any infrastructure or stacks you may have for evals, for handling chat history, or even large payloads. And again, the flexibility is really amazing. You're not locked in. You have all the options open. And so basically Temporal just brings that durable reliability to your agent infrastructure. So let's now focus on what is different about this agent skill concept. So traditionally people are building workflows with Temporal. They're building an agent loop, and they're using either an agent SDK or Temporal natively to then do the tool calls and LLM calls through activities to make everything durable. And so while that's great and works great, it does tightly couple the tools and the LLM stuff with the workflow. And also guardrails tend to be injected or prompted, which, I would give mixed reviews on. It's definitely tricky, and they're in code, which is a little bit cumbersome, I think. And so a different, I think, better way to think about this is you have your agent loop workflow, which is, maintaining your agent state, history, context, all of that stuff, and routing. And then you make a tool call to do something. That's actually a workflow that can be one step or multiple steps. And it's the guardrails we're moving from code, we're moving them into a skills.md file. So we're basically providing a skill that has a skills MD with a temporal workflow. Looking at this one step deeper from the agent loop perspective, you can see here, it's just a tool call to call a skill. Here we have Nexus. So again, we get durability at the caller and an API contract, and we're executing the skill, which is again, just executing a series or a single step potentially, but usually a series of steps. You would have like a payment or an order or something like that, and it's governed by this skills.md. So now with that said, I want to show you how this works. And first, I want to show you the skill. So if I go here, you can see I'm providing a package for my skill, my money transfer. So this is a payment skill basically. And if I open up the skill, you can see it's written in plain English. Anybody can produce this. It doesn't have to be software engineer. It's not in code. And skills are a lot more powerful than doing this with prompting because the models are trained on this. And so you're going to get a lot better results in my opinion, using this. And then you can see here, we, as part of our skill here, we have our temporal workflow. And again, this is dictating how we do a money transfer. We don't want the LLM to imagine or try to figure out. We know what to do here. We know exactly how this should work. You can see here in the run, we want a plan. We have some conditions here. We have an approval, so we can have human in the loop, which I will show you. And then we want to execute this. And when we execute it, we want to wrap it in a try catch, so we can do rollback, because with a payment, if we take money out of an account and we can't put it into the other account, we have to refund that. We have to roll back the transaction. And in Temporal, it's dead simple, and it's crash proof. And this really adds quite stuff that's really complicated and does it in a very elegant way. And so we're bringing that into the skill. So let's see how this works. I've got my application here, and I'm going to just do a simple transfer from my checking account to my savings. You can see here on the worker on the right, that's running, that's what actually does the execution behind our workflow. It's already kind of executed that planning activity, and then I can basically approve this or decline it. So this is the human in the loop. Temporal workflows are interactive, so we can create that. Oops, and you can see something's failing here. We better check that out. I'm gonna go into the workflow here, and yep, we can see here that the deposit is having a problem, but it recovered, no problem. Of course, I simulated this, but you can see kind of in real time how temporal and how this durability, reliability kind of comes into play in something that is slightly more complex than, say, getting the weather, doing a payment transaction. And I think bringing these business processes into agents is really going to be a game changer. So that's basically the payment process. Now I want to show you something else, which is, what if that deposit didn't recover and there was a problem, like we were depositing the money in a closed account. Obviously, when you create accounts and you close them, they're still around. And if you send money to them, obviously we can't take money and put money in a closed account, right? So we have to roll that transaction back. So let's see how that works in this case. You can see same thing happens. It wants me to approve it. I'm going to say yes, and you can see it comes back very quickly that it failed, and the funds have been refunded. Let's open up the workflow, and we can see here exactly that the deposit failed. And because it ran into that condition, which is a non-retriable. So you can throw non-retriables where you don't do retries. It's just a matter of putting in that and defining it. You can see here, closed account is one of those conditions, which trips our try catch, which does compensation, and then executes this refund activity, which puts the money back into the account that it was taken from. It's pretty cool stuff. Now, I can't do any demos or anything with Temporal without actually crashing the process and blowing everything up. So we're going to look at that. It's my favorite thing to do. And so now that is what I'm going to do. I'm going to go back to my original transfer here, and we are going to kill the worker. You can see here it's running. We're going to wait till we're actually in the middle of doing something. So I'm going to hit approve here, and then I'm going to go over here, and I just killed the worker. So the process that was executing our payment is gone. Not a problem. You can see in Temporal, it's just going to sit here and wait until whatever issue is resolved, and it can continue and resume its execution. So once I bring back the worker here, you can see it's going to resume, and boom, it picks up where it left off. It failed a third time because I have basically a condition in here that it's going to fail it 3 times, just for kind of example. But then it of course works as we would expect. All right. With that said, I hope you enjoyed this and it was interesting for you. You can also play around with this. That URL I'm showing you here is a live version of this application where you can experiment and see this in real time yourself. Thank you and have a wonderful day.